all right, okay. I think now it's working finally. Architecture stream today. So yeah, it's posted. We're going live. We're live now, I think. Yeah, we're live. Let me just post these. Architecture. So we're gonna do a bit of an architecture session today. Looking at Omi's design. Okay, so why am I doing this? I'm doing this because I want to make sure, it's always good to learn from. It's good to learn from others, right? It's great that we have open source, open source software out there from like very cool teams, and Omi is one of these, right? So I do have the pendant from Omi, right? So I actually have the pendant, and I also am thinking to buy the glasses. And essentially one of the things that I want to understand is because Omi is a very generic. It's one of these things where it's like an always on assistant in your computer, right? And so the idea is not only in your computer, but like you can now with Omi Desktop actually have it in your computer and basically monitor your screen and monitor your audio. So from a technical perspective, it's the challenge that one of the challenges that we're trying to solve is similar, right? So we in openLesson, and let's open openLesson, openLesson.academy. In openLesson, we're in the browser. We have our session. So we're here in the session, and then when I'm inside the session, this is preparing the learning plan and whatnot, and then essentially inside the session you have multiple ways to monitor information, and all these is basically being sent to the server to two things, right? So the way that we architected the system is like this, and that's kind of the new mode. And I think I'm gonna actually I think it should rather go. No, I think that's good. I think it's a good starting point actually. So anyway, in data input you kind of have here, audio, the muse, face detection, and then screen capture as well, right? So you have all these different things that you can actually do. And when I click start session, what is actually happening is going to pick up the microphone, which is now a Yeti microphone that I have here, that you're not hearing over to the stream. And I allow these, and then essentially now it's recording my audio, right? But then maybe I should kind of put in here some pop-up, and I'm going to take notes as I speak because I think this is our interesting thing. So add a pop-up to suggest opening data input. Oh my god, sorry for my data input. That's just a minor thing, but anyway, that's one thing. So when starting a session, right? Now, the point here is the following. So this is being recorded, and it's it's listening to you, and it's kind of trying to guide you through the session, right? So, but I can go to data. I can go to data input, and I can actually connect. Well, to be honest, I haven't tried. So I can connect screen capturing. I can capture the whole screen, right? And that's also basically now capturing the screen and sending screenshots to the server. And at the same time we can do the face analysis as well, right? So it's doing both things here. So that is good. Now while this is happening, so the way that we architected things are is our architecture, which I'm gonna also make it like open source and public, and well, I mean it's open source, but I want to document it, right? So what's happening, we'll go to Paint.js. We're old school here. No, what's the Paint.js app? JS Paint. So the way that our architecture works is like these. So we have the front end. Where do I have the thickness here? So we have the front end. So that's front end, right? So that's front. And then we have essentially two things. We have storage. So we have directly SAP-based storage. And we have Vercel backend. I know we can maybe do something like with VPS, whatever. I was just lazy. But anyway, we have it like these. And so we have a heartbeat that is, so we have two things here happening. So there is a loop, right? There is a loop. We call this the heartbeat. And what's happening is there is a loop. There's two loops. There is a storage loop and there's a heartbeat loop, right? Did I unify that finally? I don't remember whether I'm in version 2 already or not, but I think I did unify it. But anyway, it's two different things that we're doing. On one side, we are actually communicating directly with storage, and this is pure data transfer. Why is separated? Because Vercel is not like the kind of backend that you want to use for this kind of stuff, because Vercel is basically charging you for how long the process is alive, and you don't want to have long running processes in this kind of backend, right? So it's pointless. It's pointless for me to have a process that, and that's what we don't want. We don't want the data to do first here and then from here to storage, right? This makes no sense. It's like why do that when you can just have a shorter path and go this way? And what we have here is, instead, we have another mechanism here that is prompting the backend for an sort of an analysis of what's going on, and that kind of happens every 10 seconds or something like this. And what that's doing is it's fetching data from storage and from the database. Sorry, I'm lazy to use the square, so this is DB, right? It's doing the thinking, the analysis, and then it kind of comes back here with, hey, we need a new probe, we need a new something, right? So we kind of have these two processes decoupled. These, in a way, this is taking a window that is, I think, 15 seconds in the past. So the effect here is that if that's your session, essentially what we're doing is every time that the request comes in, we're taking a snapshot that is, like 15 seconds in the past, then comes in the next request, and then we do another, 15 seconds. But you see, there is an overlap, but that's intentional, right? Because, oh God, there is an overlap because we want that overlap to happen, because we don't want to miss we don't want to miss context, right? We don't want to miss context, and so we're basically using these. That's the way that we're building. I'm going to document all these. I think that's actually an interesting design, and what I want to dive in today, and we'll spend just like probably 10-15 minutes just scratching the surface for now, is, and I probably should stop these. And actually, let me check. Yeah, okay, fine. High tools and whatnot. So what I want to now do is I want to basically now take you from this design to like what Omi is doing. This is Omi on the web, and it's actually really these are conversations I've had, family chat about errands and stuff like that. The Goblin audio from the Omega Quest stuff in here. So there's a bunch of things in here, but not that's kind of the dashboard. Like it doesn't matter. Like let's not get into this right now. I want to take a look at these. And basically the system architecture, right? Okay, so I wanna let me just close a few things, because we don't need these. We don't need these. We don't need Uncle Bob. We don't need these. We don't need these. We don't need these. We don't need these. We do need these. We do need these. This is also okay. Yeah, fine. Well, the rest is okay. So that's, by the way, you can it's everything here open source, right? So, and I want to take a look at these. Okay, cool. So essentially, the Omi is a multimodal AI assistant designed to understand and interact with users in a way that's both intelligent and human-centered. So it's the backend is it's a crucial piece. We have basically it's processing and analyzing data, converting audio to text, extracting meaning, creating structured information from user interactions, storing conversations and extracting memories, facilitating intelligent chat, and integrating with external services. In a way, for us, we kind of have a set of very similar pieces, right? So the intelligent chat for us is just a bunch of tools, and it's tools, but it's also the teaching assistant that we have here. We have a canvas where you can just paint stuff while you're thinking out loud. We have a notebook. a Wikipedia, we have a practice session, a theory session, and stuff like these, right? And so that's one thing. Then we are storing the data, and we also do processing analysis. But I'm curious to understand how they actually, how do they actually, okay, do I have like here conversations, DB flow, blah blah blah, storage. Okay. Let me see. So I think they, let's start from here. So there's the system architectures. You have the client, then you have API endpoints, then we have routers, processing layers, and data storage. What it seems that it's doing is it basically seems like, I mean, that's the WebSocket. So essentially they're literally the client, what the client does is literally they do this, they open a WebSocket, right? So we don't do these, we actually have directly the loop in the client, but what they're doing is they're passing all the information to the API. They're doing the transcription in here, so they and then essentially it, and here it goes kind of two ways. So there is basically it goes to speech to text, and then it goes to Google Cloud Storage. Yeah, which is pretty much what we're doing. That's our kind of loop. Now, I'm not so sure, I don't think here, this is just system architecture, so we need the diagram flow probably to understand where the loop is. So we need to understand where the loop is. And I had seen that real-time transcript. I think that's what's happening here. Is it here? I had it open here. Listen and push pipeline. Listen and pusher pipeline. So, okay. So this is in 2026 March. The real behavior observed during end-to-end testing with live services, backend pusher diagram. Okay, so let's look at these. Essentially, okay, so we've got the client. There is the backend. They basically it opens. Okay, so it opens a, so it's def token check. It creates objects in the data, and then it starts the socket. And this is the loop, audio streaming. So there's PCM audio bytes, update last activity time, forward audio, transcript segments, update finished at only on real segments, and then write transcript, and then essentially back with segments. So it's, yeah, I mean, in a way, it's like it sends audio bytes. Now, let's see if these. So, how big are the audio bytes? The PCM audio bytes. How? Like, are you just sending? Are they chunking the audio? I think they are probably chunking the audio, right? Binary frames. So there's a silent skip alive specifically with okay. You know, that's actually smart. I don't have these, but I need to be listening to. So I don't have these, but I need to be able, because let me check. So do we have? So that's definitely an interesting thing. But there's no disconnect path. It's good. Pusher reconnect and pending flash. Speaker ID lifecycle. That's how they distinguish multiple voices. Private cloud sync. Audio upload. And I think that the difference is really the like, okay, timing constants, conversation timeout. I think chat system architecture. User question, line graph router, Okay, so there is no context path, an agentic path, and a persona path. Streaming response, no context path. So now the question is, where does this fetch simple greetings, classification criteria from the grass context? Okay, cool. Classification logic. The agentic tool system receive question, decides tools, execute tools, synthesize, continue, generate answer. Action items, conversation memory tools. Okay, so they have tools basically. Conversation memory tools, get conversation tool. Yeah, okay, so actually semantic search. But I'm curious. Vector search deep dive. So when is the system making usage of the audio / transcribed data? Sorry guys. And I think it's better like this. Better like this probably. Yeah. Okay. So PCM audio is forwarded to DeepGram for real-time STT, and then speaker ID audio sent to the embedding API. Yes. Okay, so use these embeddings to get the speaker ID. Conversation processing, saying chat. Okay, so essentially get conversation tools and search conversation tools are, because I think the difference here and the challenge is that we need a much more real-time monitoring of what's happening. I mean, no, not really. I mean, this also needs to be real time, right? Because I maybe just be doing something and I might want to ask, whatever, and then it's kind of like looking at the screen. Yeah. So, what does PCM stand for actually? Oh God. So essentially we are actually, I think our architecture makes a lot of sense and it's very similar, but it's simpler. I think maybe it's just not, we're still early. We don't have so many users. Maybe it's not too much well thought through in terms of scalability. For early samples. Okay. Yeah. All right. Sure. But I mean, okay, so what else do we have in here? Backend setup. Let's just go one by one. The backend setup, again, parse capabilities. So the flat client, your backend, class storage, external services. Do they use DeepGram from? Really? Like they should definitely use Grok, and I think I'm actually switching to the Grok API today. I think I'm switching to the Grok API for kind of both. I want to try both ways, right? So I want to see if I can. Text. So it's text to speech and speech to text, because I think that's going to be a great experience for that part here, where essentially the tutor is going to be able to talk to you as well, right? I think that makes a lot of sense. And also basically whatever you're saying, the transcription is probably going to be faster. We'll definitely try that. So that is for sure one thing that we will do today. But okay, let's see. So they use these for Pinecone, Redis, blah 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 blah. Back in deep dive. I mean, it's nothing. I mean, it's yeah. It kind of like, I don't know what I expected, but I think that just makes sense. They have it separated like we do in terms of there is one pathway from an architecture perspective where that is basically just taking care of transcription and storage, and then there's another path that deals with the conversation, which then actually fetches from the binary. It fetches from the conversations. It's interesting. It does actually fetch from the binary files as well. If you pay attention, there's this arrow here, and from the vector encodings. So it does fetch from everything, which in a way it's kind of the same, like the same we do. I'm just using Supabase for these, and maybe I should just at some point migrate when I want to scale these. I have not at all paid attention at the sort of costs of the decisions in my architecture. But essentially that makes a lot of sense. Yeah, I don't know. I kind of feel like it's almost like yeah, kind of like it I don't know, somehow confirms the architecture that I'm using kind of goes down the right path, even though it's maybe not 100% built for scale. Conversation like cycle starts in progress. That's different because we're not dealing with conversations like these. Yeah, I mean, I think that's good. I think that's just good. I might want to add some layers to one of the things that I might want to do is add a knowledge, or add sort of not a knowledge graph, but basically maybe like compress context as the session goes on that the LLM tutor can use anytime as extra context. And because I think that's exactly what needs to happen here, right? So like the modus operandi of these is, I have my session plan here. What do we already know about blockchain immutability and cryptographic hashing? You have your tutor, and so you start building on these. You start talking and discussing, and then you might ask my practice, blah blah blah. So that you should by the way, we should lock all these resource practice, ask and done. At tool logging for for ask practice what am I doing? Ask and done. And I think guys, I think we have a very good architecture actually. So in manual mode we have like the different things to split, and then yeah, I think this makes a lot of sense, to be honest. You have these, and then you kind of have your session plan here, and your tutor, and then your tools. And again, you might be working off of another, another screen, another display, if you're working on something else, and then you just kind of pull this back up. Yeah, I think it makes a lot of sense. I think I need to review these today, because I want to make sure that this data is the way this is implemented is really like perfect, and that the same happens with the mobile app, so to say. Now, guys, I think it's good. I think I'm happy. This was a short session, but I mean, I don't know. I don't want to dig too much, because there's a lot of details, but I don't really care so much about the details. I just was curious about the overall architecture. Transcription flow is like, okay, connect audio chunk, backend, forward audio transcription result, text segment plus speaker, yeah, and then close connection session ended. So it's like it's a loop. I mean, how else do you want to how else do you want to basically design these, right? I mean, it's basically that's what it is. What they do differently is they kind of build context and build things that then the conversation modules basically analyze, and for us it's a bit more simple, right? But maybe we can use something similar. So we're kind of creating a knowledge, like a knowledge graph in the background or something like that, that kind of builds out of what I'm saying, what I'm talking through, what I'm learning, and the tutor kind of can pull information from that, condense information from that, maybe, and maybe it's something that somehow I show here in the tutor. I might actually do these. I might actually do this. I mean, I don't know. I'm thinking, because this in a way kind of builds up on like what you're talking about, and this might be an interesting thing to explore. So show into the panel the session graph that has been built. I think it can be interesting because this session graph can kind of basically expose some of your thinking flaws or your thinking process, right? That's just an idea, but it's a good idea, I think. Anyway, thank you guys. I'm gonna wrap it up here and see you tomorrow.